Good evening, everyone. I hope all of you are well. Let's say we have a queue like this. Okay. By the way, left to right, will be moving. This is a linear queue. So this is index 0, index 1, 2, and 3. And initially, we are assuming that you have two pointers, head and tail. So head will always be used to remove the values from, and tail will always be used to add the values at. जैसे आपके पास real life में जिस तरह से चीज काम करती है. So you can imagine, let's say, if this is some sort of order. Okay, so maybe this is some sort of an ordering kiosk, और आप लोग इस तरह से line up करोगे from the starting from the left side. Okay, so how does it actually work? So अभी हमारा head or tail, let's say there's both pointing at 0. Again, depending on the implementation that you have done. So I enqueue the value 12. Now the tail moves to 1 now, because the next value will be added to index 1. And if I want to remove the value, it will be removed at the head index, which is 0. So I remove it from here, and 12 is gone, and head is also now pointing to 1. So stack के अंदर आप लोगों को याद होगा कि there is one pointer only, and secondly, stack में it moves the top, we do increment by 1 or decrement by 1. In queues, हमारा जो head or tail है, they always move to the right side. Okay. We always increment the value by 1. We can't decrement the value. अगर आप 0 पे हो तो अगर आप decrement करोगे तो you'll just go out of the array. Okay. So next time I input, so I'll clear the queue. So 12 NQ. Then I add another value. So it keeps on adding them at the tail. And tail gets incremented by 1. So 3. Now I add 35. And maybe now I have 9. Okay, so I have these values. Now tail is pointing at index 5. This is where the new element will come. And head is pointing at 0. This is the values would be removed from. So again, if you are at the order kiosk, or if you're done with the order, so you will leave the queue, and then we will simply move the head to the next person that is in the queue. And that is what's happening here. So if I DQ now, so DQ will remove the value from the head, and head will now point to index 1, which is this. I remove the value from index 1. Now the head is pointing to index 2, which is 13, which contains the value 13. If I DQ again, then the head points at index 3, which is 35 value. So next time I want to add a 0 here, so 0 is added at the tail. Okay, so head पे value remove होगी, tail value add होगी. So if you understand till this point, then there's only two things worth knowing. That is, when I keep on DQing the value, so there comes a point when the head and tail would actually be equal. So यहाँ पे हमने जो है ना implementation में दोनों में 0 0 से start किया, तो ये आपको exam में थोड़ा देखना पड़ेगा. Because we started from 0 0, and now in fact इसको दोबारा से try कर लेते हैं. So 12, and if I DQ this, so आपका head और tail same value पे point करे. This means in a linear queue, it means कि आपके पास कोई array में element नहीं है, आपकी queue में कोई element नहीं है. But अगर आपकी implementation में -1 से start हुई होगी, so उसके अंदर जब आपके दोनों values एक ही index से point कर रहे होंगे, head और tail, so that would mean कि there is one element in the array. वो जब implement करेंगे तो वहाँ पे आप लोगों को clear हो जाएगा. And other than that, if I try to DQ the value again, so let's say if I try to DQ, so there's no value here, let's NQ two values. Okay, I'm going to DQ these both. So head becomes 2, and then I DQ it again, so it becomes 3, and then the queue is empty. But अगर आप -1 से again start करते हो तो उसमें आपका जो head है वो eventually would exceed the tail value. Again depends कि आपने कौन सा match use करना है, 0 1 0 से start करने वाला या 1 से start करने वाला. So we have to first talk about from the perspective of paper 2, जिसमें आप लोगों को इसका कोड नहीं आएगा, तो आपने इसमें बताना कि you have to create a 1D array of a certain size of, let's say, data type integer or string, जो भी question की requirement है. You will have a head pointer, tail pointer, इनके भी आपने types बतानी है, declare करना है. Then you will initialize both of the pointers. So initialize both pointers to represent an empty queue, and then you will have some sort of a size of queue, or you can have the value in the queue, how many elements you have stored. Then you will implement enqueue to add value at the tail pointer, and then dequeue, etc. Okay, so linear queue मैंने आप लोगों को explain किया था. Just a quick recap of it. Head or tail, we're starting from 0, again depending on the question. So if when you try to enqueue and there are already 5 elements in the queue, so आप लोग इस तरह में implement कर सकते हो, or you can do it by just using the just a second, by just using the uh, head and tail method. Okay, so we don't need to add the number of items in the queue. ये हम circular में भी use कर सकते हैं. So again, totally depends on the logic that you're trying to use. Okay, so यहाँ पे I'll get rid of it. I can simply check if the current tail. So since we started from 0 and then we're incrementing by 1, so if tail becomes more than the size, which is 0 to 4, that is 5. If tail becomes greater than 5, that means that the queue is full. Otherwise, whatever the item is, you will save it at the tail pointer and at in the queue, and then increment the tail by 1. Again, literally the same logic as we did here. So you will save the value in the current tail pointer of the queue, and then you increment the tail by 1. So tail is now pointing to 4, which is the next variable index. And then we don't need this as well, and we end if, and then we end the procedure. All right, so then the next part was DQ, and DQ में what we'll do is कि हम जो भी value को delete करेंगे अपनी queue में से, we will just return that. Right, so if I press DQ, so I basically have to get rid of 12, but we do not get rid of the values, at least in paper 2's point of view. हम उस value को जो है सिर्फ save करके return कर लेते हैं. So अगर दोस्त ने string return करनी है तो या integer return करना है, whatever it wants to return. So if head becomes greater than tail, or if head becomes equal to tail, again depending on the implementation, तो आपकी queue empty होगी and then you will return an empty string. Otherwise, आपके head पे जो भी value है, you will save that in a variable and you will increment the head by 1. Again, if I press DQ here, so head is incremented by 1 and the value is gone. So basically, we want to delete the value, we want to make it empty or something. हम head को simply +1 कर देंगे and then we will return the value that we deleted. Point being कि next time if you add a new value in your queue, तो वो in any case उसको override कर देगी. So it doesn't really matter. And then you don't need like really need the procedure for peak, but this is literally just going from 0 to 4 and हम हर दफा q की value में print करें. Then we can just call the enqueue function and then we can just call the dequeue function however you want to do it. और dequeue में हम उसको call नहीं लिखेंगे because it's a function. Okay, so this was your linear queue. Now we have what we call the circular queue. Okay, circular queue is quite interesting. So circular queue का concept ये है कि अब जैसे आप लोगों की queue technically ये empty है भी. So let me actually add values quickly. So tail is pointing at 13 and 8. Okay, tail is pointing at 14 now. Okay, you guys can clearly see that there are 3 empty slots in the start. We still have 3 slots open in the start. But अगर हम अपने simple queue के अगर हम implementation पे जाए and we're saying if the tail becomes greater than 5, or in our case if the tail becomes greater than 14, that means that the queue is full when it is clearly not. So then we try to implement it like this. This is what we call a circular queue. Obviously, we literally won't be drawing a circle, but this is just to give you an idea. The idea is that when you have enough space in the queue, and even if you hit the boundary of the queue, so you will just wrap around to the index, starting index, which could be 0 or 1. So just 10, 20, 30, 40, 50 kare, and let's say the 0th index is 3. So from index 7, I'll go back to 0. Similarly, यहाँ पे if I try to add in maybe another value 44, and if I go at my linear queue implementation, now it should say that the queue is full because my tail has exceeded 14. But what we'll do is we'll simply check if there's enough space. How are we checking the space? We are keeping a count of number of items in the queue. So number of items in the queue is basically 11. So we have space for 3. So what we'll do is we'll bring the tail from 14 back to index 0, and you can clearly see यहाँ पे भी tail जो 0 हुई है. So then I add another value and it will get added at the 0th index now, like this. We'll increase the speed. Okay, let's start dequeuing now. Okay, so ये हमने head से values remove करना शुरू की. So dequeue, I'll keep doing that. 13, 14. Okay, now it's at 14. Okay, and again we will have a count of values. So since we know that there's still one more value, and we know that the value will be removed here, so from 14 we'll go back to 0. This is linear circular queue. कि आप अपने बाउंड्री इंडेक्स पे जाके आप रैप अराउंड करके स्टार्टिंग इंडेक्स पे आ जाते हो. सो व्हाई वुड वी डू दैट? बिकॉज we don't want to waste space as we do in linear queue. So if I dequeue this 44, now head is pointing to index 0 now, which you guys can clearly see that head say is at 0 and tail is at index 1. And if I dequeue this again, now it's back to the original empty form. ओके, अब हम सर्कुलर क्यू को इम्प्लीमेंट कैसे करते हैं? सो सर्कुलर क्यू के लिए वी नीड द नंबर ऑफ आइटम्स. इसकी ना बहुत मल्टीपल इम्प्लीमेंटेशंस है, ये मॉड वाली भी होती है, रैप अराउंड और ऑल ऑफ दैट स्टफ, बट I'll keep it very simple. So we'll just use the number of items. First we check if the number of items is equal to 5, then that means the queue is full. Otherwise, the same thing, you will put the item on the tail of the queue and then you will increment the tail by 1. Okay, and now at this point you check if your tail becomes equal to 5. So we are doing 0 to 4. In fact, if it becomes equal to 4, then we will reset the value of tail to 0. Okay, literally same logic here. When we were at 14, so we saw okay, there's space and we go all the way back to index 0. Okay, and we increment the number of items by 1. Again, why are we keeping track of number of items? So that we can know that we have enough space in the queue. So abhi just say if I delete the values 10, 20, 30, so that means that we have 1, 2, 3, 4, 5, 6 slots open. So जब तक आपके 6 slots fill नहीं हो जाते तब तक आपके जो pointers है वो wrap around करते रहेंगे. This is called wrap around, by the way. I should write this wrap around concept. Okay, for DQ I do the same thing. I will check if the number of items are equal to 0, then the queue is empty. Otherwise, whatever the value at head is, I'll save it in some variable, and then I'll check that if the head becomes more than 4, then I'll set the head back to index 0, not 1. Index 0, and then I will decrement the value of number of items by 1. Again, same logic here. So यहाँ पे आपने NQ किया, DQ किया. So DQ, NQ is all the same. बस इसमें एक additional check ये है कि जब भी आपका boundary hit होगी आपका index ही, तो you will bring the value back at the starting index. That's it. This is circular queue and linear queue. So linked list is a very interesting concept. Linked list में what we do is, so एक चीज आप लोगों को linked list के बारे में बताना चाहिए, that is it is a non-linear data structure, ADT. So linked list में what happens is कि आप लोग जो syllabus में जब इसको implement करेंगे ना, तो we will be doing it using 1D arrays or 2D arrays. ठीक है, और हम P4 के अंदर भी इसको we'll do it in multiple ways. We'll do it using object-oriented programming, and we'll also do it using 2D arrays. So there's going to be a lot of code in linked list. For now, linked list क्या होती है? अगर हम इसको 2D array के तौर पे imagine करें, so it's simply like this. You have a 2D array 0, 1, 2, 3, 4, 5, 6, and then here you have the column 0 and here you have the column 1. Okay, what do we do in these and how do they work? So column 0 pe, let's say I have 30, and next I say is at index 3. So then next I go to index 3, I say this is 445, and then next I go to index 6, and then next I go to index 6, I save 70 here, and then I say okay, this is the end. So this would be a null pointer now. Okay, अब ये क्या मैंने किया ये मैं आपको बताता हूँ. So null basically means -1 in pseudocode. ठीक है, null pointer means कि end of linked list. Okay, how does linked list work? So linked list को हम इस तरह से draw करते हैं in real life. This is a series of nodes that are connected to each other, and then it is non-linear. Non-linear का क्या मतलब है कि अगर आप इसके indices देखो, so I started from index 0, then I went to index 3, then I went to index 6. So I didn't go 0, 1, 2, 3, 4, 5, 6. So यहाँ पे जब मैं 30 read किया, तो I said okay, from 30, now the next value is at index 3. So I go to 3 पे value है 45, so I put 45, and then I say okay, the next value is at index 6, so I go to 6, and 6 पे हमारे पास पड़ा हुआ 70, and then this is the end of linked list. इसका like this is a very powerful tool in real life as well. अगर हम इसके uses की बात करें, तो it is used in real life. So सबसे पहले तो ये आपके जो आपकी जो हिस्ट्री ट्रैकिंग होती है वो इस पे लिंक्ड लिस्ट के ऊपर हो रही होती है. फिर आपकी जो मेमोरी की एलोकेशन और डी एलोकेशन हो रही होती है वो लिंक्ड लिस्ट से हो रही होती है. So linked list actually has a lot of real life uses. Or if I Google quickly, so linked list applications. So all the ADTs that you are studying right now, these are all going to be retaught to you in university. अगर आप लोग आगे bachelor's in CS करते हो, से देखो dynamic memory allocation, then ये आपके use होते real world scenarios like music playlist, like undo redo. So I know हमने उसमें भी देखा था queues और stacks में, so kind of overlap आ जाता है इनमें. Operating system में आपकी process scheduling में etc etc etc. So इसके ऊपर अगर आप जाके देखोगे ना linked list interview questions, so you will come across a lot of interview questions that are related to linked list, because this is a very you can say popular topic amongst the interviewers are to judge your concepts. So all of the stuff that you do in this subject is extremely relevant in real life. Okay, so this is the concept of linked list. अब linked list के लिए आपके पास इसमें दो pointers होते हैं mainly. एक आपके पास head pointer होता है, that is you basically tell that where is the linked list starting from, because if you do not know that then आप इसको non-linear fashion में नहीं चला सकते. So linked list हमारे केस में 0 से start हुई है, so our head pointer would be pointing to that. Then there would be another pointer that is called the free list pointer. So free list pointer क्या करता है? It simply points to the next available index. So this will be pointing to the next available index in the array, which is simply our linked list for now. Okay, so array हमने linked list से ही करनी है. All right. अब next हम इसमें लिखते हैं, let's say we have, okay, and the free list pointer will be pointing to the next available in the linked list. So we have 1 2 3 4 slots free right now. So अभी for now हमारा जो free list pointer वो point करेगा index 1 पे. यहाँ पे this would be our free list pointer. और इन सब के जो indices हैं they could be all -1s again, और या फिर null, इसको हम जिस तरह से मर्जी सेव कर लें. Okay, so next time you want to add a value, so it will go at index 1 and maybe so let's say मैंने अब 70 के आगे की value add करनी है at the tail of the linked list. So maybe this is 99 and I'm going to save this at index 1 and then this would become null now. So इसका जो next है वो null हो जाएगा, और जो इसका 70 का जो next pointer है we will update that to point to 1, और इसका जो next था वो 3 पे point कर रहा था और इसका next 6 पे point कर रहा था. Okay, so if I go to my array now at index 1 I have 99. 99 का next -1 पे point कर रहा है because it is the end of linked list. But अब जो 6th index पे हमारे पास 70 है, 6th index पे we have 70 here. इसका जो next है now this is not -1 anymore. This is going to point to the new value that is basically 99, और 99 पड़ा हुआ है index 1 पे. So this should change to 1 now. So if we again restart and let's see the order of our linked list. So how would it work? Let's see. Okay, so this is the head pointer. ये मैंने वहाँ पे label किया हुआ था. So head pointer is at 30. So we start from index 0. ठीक है. Then we go to index 3. Then from index 3 we go to index 6. Then from index 6 we go to index 1, and from index 1 we here we are यहाँ पे 99 पे और 99 के next पे -1 है, so ये बाकी ये indices आ गए. ठीक है, 0 3 6 1 again. So this is the idea of a non-linear data structure. This is going to be implemented with arrays, but इसकी जो पूरी logic है वो non-linear जो है वो आपका data structure होगा. It will work as per the free list pointer and the head pointers. So linked list का again code आपका test नहीं होगा P2 में, so you need to know the theory of it. So आपसे description मांगेंगे exam में कि how can you implement a linked list. So you will say you will have two 1D arrays. So either you can have two 1D arrays or you can have one 2D array. So two 1D arrays हमें तब चाहिए होंगी जब let's say आपका data string type का है but आपके जो next pointers है वो integer types के हैं. और 2D array आप तब यूज कर सकते हो जब आपके दोनों data types में भी दोनों integers हैं. So one for data, one for pointers. Then elements from the same index represent one node. So node का मतलब ये होता है कि ये जो आपके पास data और next का जो pointer आ रहा है ये एक node है आपके पास, दोनों elements बन के एक node बनाते हैं. Then we have an integer for the start pointer, or you can explain its use, and then we'll have an appropriate value for null pointer, which would be -1, and then we'll have a variable for free list pointer, and then we will have routines that we would need to add, delete, search in the linked list. ठीक है, अब इसके अंदर और भी multiple जो है ना आपके पास फंक्शनैलिटीज होती हैं. सो अगर हम स्टार्ट की बात करें तो स्टार्ट में क्या होता है ऐड की बात करें तो ऐड एट स्टार्ट होता है, एट एंड होता है और एट एनी इंडेक्स होता है. Similarly delete की बात करें अगर हम, तो delete at start होता है, delete at end होता है, and at any index होता है. And if we talk about search, तो ये सब algorithms हैं, ये आपके again paper 3 और 4 में आएंगे, but not in paper 2, so we'll eventually do them. ये आप लोग देख सकते हो कि इस तरह से implementation हुई है. So यहाँ पे अगर string data है और आपके पास pointers integer में, so you will need to make 2 1D arrays. So everything else would remain the same as I taught, just उनमें जो आपके array के names है वो change हो जाएंगे. So in order to initialize a linked list, this is what we do. अगर आपके पास 1 to 5 1 to 6 indices हैं, तो आप 1 to 5 में you will simply put -1 at all the column 1s at the data column, और जो भी आपकी column 2 है, जो next pointer होगा उस पे आपकी जो भी current value होती है उसके +1 कर दीजिए. So by the way, this is not a hard and fast rule, but this is how we generally initialize a linked list. So जब x की value 1 होगी तो this would be 2, जब x की value 2 होगी this would be 3, then 4, then 5, और आखिरी जो आपका element होगा linked list का उसके हम next pointer को जाके -1 कर देंगे, null कर देंगे. So null pointer simply means that this element is not part of the linked list. Linked list की जो chain है ना वो उसका part नहीं है, so उसको हम -1 उसका next जो है वो कर देते हैं. So let's say I want you to print the linked list, or you want to search through the linked list. So we've kind of already done this. So what we have to do here is that we start from the head pointer. ठीक है, so हमारा head pointer let's say अगर index 0 पे है, so index 0 पे data is 30. So I'm going to print 30. Then I have to go to the next index, so I cannot go to index 1. This is not a queue or a stack. Instead, I will look at the value in column 1, which is 3. So then I will go to index 3 and I will print the value at column 0 here, which is 45. I'll print 45, then I'll look at the value at its column 1, which is 6. I will go to 6, then I'll look at its column 0 data, column 1 next है, और यहाँ पे आपके पास पड़ा हुआ है let's say I think 90 था, and then 90 के next पे आगे 1 है. So I'll go to index 1 and then I have 99 there, and then it says -1, so that means कि बस आपकी linked list end हो गई है. So simply put, जब आप इसका कोड लिख रहे होगे या जब आपसे एग्जाम में लॉजिक पूछेंगे, तो we will simply be writing that while the next pointer is not equal to -1, जब तक आपकी वैल्यू -1 while next is not equal to, हाँ जब तक -1 नहीं है तो तब तक आपने इसको जो है वो लूप वो अपने नेक्स्ट एलिमेंट पे जाते रहने. नेक्स्ट एलिमेंट पे कैसे जाएंगे? सो लेट्स से इफ आई हैव अ करंट नोड, आई विल सिंपली से दैट मेरे जो लिंक लिस्ट के करंट जो भी आपकी वैल्यू है उसके इंडेक्स 1 पे I will be going. So let's say current was initially 0. So 0 के index 0 के column 1 पे क्या पड़ा है? 3 पड़ा है. So current becomes 3 then. So I'll save 3 here. Then the loop runs again. Next time I have 3 here. Then I go to the third index. I go to the column 1 of it, which is 6. So यहाँ पे आपके पास 6 आ जाएगा. Then you run the loop again. So on and so forth. इस तरह से आपकी लिंक लिस्ट ना खुद ही आगे जाती जाएगी. Again, when we implement this in code, so it would make more sense. अभी के लिए this was all the theory that you guys needed to look at. ठीक है? Okay, now we need to discuss some algorithms. This is a very good website. Basically, इस पे आपके animated तरीके से you will be able to see how the linked list is going to work. So we are going with a very simple linked list, and I am going to first add a value at the tail. So tail simply means कि आपने end of linked list पे value add करनी है. So यहाँ पे क्या होगा? जो भी करंट हेड पॉइंटर है वो आपका 12 पे पॉइंट करेगा और 12 के नेक्स्ट पे नल होगा. Then maybe I have 1. So now what happens is that you add the index 1 into your array, and then जो भी आपकी लास्ट वैल्यू होगी उसका नेक्स्ट आपके 1 पे आ जाएगा और 1 का नेक्स्ट नल पे आ जाएगा. Then maybe I have 99 at the end. So it goes through the end of the linked list until it encounters -1. So जहाँ -1 आएगा वहाँ लिंक लिस्ट एंड हो गई होगी, and then जो भी लास्ट एलिमेंट होगा उसका नेक्स्ट आपके करंट एलिमेंट पे आ जाएगा. दिस इज inserting the value at the end. Then if I want to insert the value at the start, so if I want to insert the value at the head of the linked list, so ये आप लोग देखो यहाँ पे क्या होगा. Initially the head was 12, so we bring in a new value and we say that जो भी new value का next है वो current head पे point करेगा. So current head was pointing to 12 right now, and then since they both are pointing to the same thing, so we can break one of the pointers and we can say now the head pointer is supposed to point at index 0, the value 0, which is the new value. Similarly, if I have another value 100 and I want to insert it at the head of the linked list, same thing will happen. It will literally just point the head to the current value, the new value, और new value का जो next है वो previous head पे आ जाएगा. And then if I want to delete the value from the tail, so tail की value delete करने के लिए I will go all the way till the end until I get next is -1. ओके, और यहाँ पे क्या होगा कि जो भी आपकी लास्ट वैल्यू जब -1 आपको मिल जाएगी तो आपने उस वैल्यू से जो प्रीवियस वैल्यू थी उसका नेक्स्ट नल कर देना है. यानी कि यहाँ पे 1 वाज पॉइंटिंग टू 99, राइट? सो 1 का जो नेक्स्ट है उसको नल कर देना. सो लेट्स डू इट अगेन. अब हमने 12 का जो नेक्स्ट है उसको नल कर देना है, एंड देन टेक्निकली 1 इज गॉन फ्रॉम द लिंक लिस्ट. इफ आई डू इट अगेन, हमने 0 के नेक्स्ट को नल कर देना है और ये 12 इज आल्सो गॉन फ्रॉम द लिंक लिस्ट. एंड इफ आई वांट टू डिलीट अ वैल्यू फ्रॉम द हेड, सो व्हाट आई विल हैव टू डू इज कि जो भी आपका करंट हेड है वो जिस पे नेक्स्ट पे जिस पे पॉइंट करे ना उस वैल्यू को आपने हेड बना देना, एंड देन यू विल गेट रिड ऑफ the 100 by making its next to -1. So if I do this, तो ये देखो इस तरह से it's gone. ठीक है, so ये आपकी लिंक लिस्ट की बेसिक एल्गोरिथम्स है. They look very simple when discussing, but if I show you their Python codes, so it might come off as a little bit of a surprise because of how lengthy it is. Binary trees, linked list, yes. So ये unordered linked list का सिर्फ ये कोड है. So this is insert at the start, insert at the end, insert at any index, then delete at the start, delete at the end, and delete from any index. And this is just like one part of it. Then we have ordered linked list. So उसमें आपका linked list automatically order maintain करती है. And then we have to actually do this using linked list method, using the object oriented programming as well. So उसके लिए हमें linked list दोबारा से करनी पड़ेगी. So you know there is a lot of work that needs to be done when we talk about Python. But for now, this was the whole concept. Okay.